Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology, a small part of revision from section A and a new chapter from section B. In the beginning, we will just revise the numerical examples which are left out for second chapter, and then we will start with a new chapter, chapter number 8, useful and harmful microbes from section B. So let us begin with the revision for the solved examples for chapter number 1, page number 1616 in your textbook. The mass of a cannon is 500 kg and it recoils with a speed of 0.25 meter per second. What is the momentum of the cannon? Mass is given and speed is given. Recoil speed. Speed means what? Velocity. So mass is given in kg. So first you will write what is given. Mass of the cannon m is equal to 500 kg. Recoil speed is 0.25 meter per second. Let us check the units. Both the units are in MKS system, so need not do any type of conversions. What is the momentum? Now you all know the formula for momentum is mass into velocity. So write the formula. Momentum is equal to mass multiplied by velocity. 500 multiplied by 0.25, that comes out to 125. Now the unit of momentum in SI system is kg meter per second, and if you verify you will get C. Mass is kg, so kg, and speed is meter per second, so kg meter per second. So your answer is 125 kilograms meter per second. Very simple, just writing the formula and substituting the values. Next solved example for revision is on the same page, page number 16. Solved example number 2. Two balls have masses of 50 grams and 100 grams and they are moving along the same line in the same direction with velocities of 3 meters per second and 1.5 meters per second respectively. Two balls, they have masses 50 gram and 100 gram and they are moving along the same line in the same direction with the velocities 3 meter per second and 1.5 meter per second respectively. They collide with each other, and after the collision the first ball moves with a velocity of 2.5 meter per second. Calculate the velocity of the second ball after collision. Two balls, they were moving along the same line in the same direction with different velocities. They collide with each other, and after the collision first ball changes its velocity to 2.5 meter per second. You have to calculate the velocity of the second ball. First thing, you will write what is given. Mass of the first ball you will take as m1, and for the other ball you will take as m2. Similarly, velocities you will take as u1, u2 and v1, v2. So mass of the first ball m1 is 50 grams and other units are in meter per second. So we will convert this grams into kg. So 1 kg is 1000 grams. So divide 50 by 1000, you will get 0.05 kg. Mass of the second ball m2 is 100 grams. Divided by 1000, 0.1 kg. Initial velocity of the first ball. The first ball was moving with a velocity of 3 meter per second. So u1 is 3 meters per second. Initial velocity of the second ball u2 is 1.5 meter per second. Final velocity of the first ball is after collision. The first ball moves with a velocity of 2.5 meter per second. You have to find out the second ball's final velocity, that is v2. Now here you have to apply the concept of law of conservation of momentum. So according to the law of conservation of momentum, total initial momentum is equal to total final momentum. So what is the formula? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Substitute the values. M1 is 0.05 multiplied by U1 is 3 plus M2 is 0.1 multiplied by U2 is 1.5 is equal to M1 0.05 multiplied by V1 is 2.5 plus 0.1 multiplied by V2, which you have to find out. Solve the brackets. 0.05 multiplied by 3 is 0.15 plus 0.15 is equal to 0.05 multiplied by 2.5, 0.125 plus 0.1 V2. Add both this, you will get 0.3 is equal to 0.125 plus 0.1 V2. Right hand side remains the same. Now 0.1 V2 keep over here and shift this on the left hand side, so it will become minus. So your V2 will be 0.175, which is 0.3 minus 0.125. Here you have to be very precise, very thorough with the mathematical part, with your calculations. Do not do anything verbally. You have your rough work side, or on the last page you can do the calculations and then enter the values. Do not do scribbling. Most of the scribbling will make you lose your marks unnecessarily. So 0.175 upon 0.1. So when you divide 0.175 by 0.1, you get as 1.75, and it is velocity, so meter per second. And this is your answer. Final velocity of the second ball V2 is 1.75 meters per second. Very easy sum. First thing is check out for the units. We have converted the masses of grams into kgs. Then we have written what values are given. Law of conservation of momentum formula is applied. Values are substituted. Working out is done, and finally you will get the answer. Be very thorough with the calculations. With this we complete with the revision of solved examples. Now the revision of question number 7, numerical, textual numericals is remaining. Let us do them quickly. Question number 7, first one, very simple. An object moves 18 meter in the first 3 seconds, 22 meter in the next 3 seconds and 14 meters in the last 3 seconds. What is its average speed? 3 distances are given, so that we will first write down what is the total distance. 18 meter plus 22 meter plus 14 meter, that comes out to 54 meter. Now let us calculate the total time. So the total time is, in the first case 3 seconds, second case 3 seconds, third case 3 seconds. So 3 seconds plus 3 seconds plus 3 comes out to 9 seconds. You have to calculate the average speed. Now as I have told you, if you have to calculate average marks, what you do? You add up the marks divided by number of subjects. So here what it will be, average speed is total distance travelled upon total time taken. Substitute the values. 54 upon 9. So 9 6 the 54 meters per second. So your answer will be 6 meters per second. So the average speed of the object is 6 meters per second. A very simple sum. Similar to that, you have one more example, 7D. We will move towards that later. Now we move towards the next sum, question number 7B. An object of mass 16 kg is moving with an acceleration of 3 meters per second square. Mass of the object is 16 kg, moving with an acceleration of 3 meters per second square. Calculate the applied force. If the same force is applied on an object of mass 24 kg, how much will be the acceleration? So here the sum is divided in 2 parts. First part, they have given you mass of the object, acceleration, and you have to find the force. Taking that force into account, they have given the mass of the next object, you have to find the acceleration. So let us work out. First case, mass is 16 kg, so m is 16 kg. Acceleration A is 3 meters per second square. Calculate the applied force. So you have to find capital F. Use the force equation. F is equal to m multiplied by A. Substitute the values. 16 multiplied by 3. That comes out to 48 as it is force. And the units are in MK system. The value is 48 Newton. Now if the same force is applied, means this force of 48 Newton is applied. So second case, force is 48 Newton on an object of mass 24 kg. So mass here is 24 kg. How much will be the acceleration? You have to find small a. Formula again the same, F is equal to m multiplied by a. Substitute the values, force is 48, mass is 24 multiplied by a. 48 divided by 24, so 24 2s are 48. A is 2, acceleration, so unit is meters per second square. Very simple sum, go through it. Next sum, question number 7C. Just now we have seen one solved example, a same type of sum. A bullet having a mass of 10 grams and moving with a speed of 1.5 meters per second penetrates a thick wooden plank of mass 900 grams. Two objects are there, one is bullet and one is the wooden plank. Let us write what is given. Mass of the bullet is 10 grams. Mass of the wooden plank is 90 grams. It is 900 given in the textbook. Just change it to 90. Now you have to convert this grams into kg. So divide by 1000 and just write it kg. If you want, you can work out over there. The bullet is moving with a speed of 1.5 meter per second. So U1 is 1.5 meter per second and penetrates a thick wooden plank of mass 900 gram. The plank is at rest. So U2 is 0 meter per second because it is at rest. So velocity is 0. So U2 is 0 meter per second. The bullet gets embedded in the plank and both move together. Now both have started moving with the same velocity. You have to determine their common velocity. You know the law of conservation of momentum. So if you want, you can add one statement. According to the law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Substitute the values as we have done in the previous solved example. m1 is 10 upon 1000 multiplied by 1.5 plus m2 is 90 upon 1000 multiplied by 0 is equal to 10 upon 1000 multiplied by v1, and v2 is same now because both are moving with the same speed. So let us take it as v in both the cases. 10 multiplied by 1.5 comes out to 15 upon 1000 plus anything multiplied by 0 comes out to 0 is equal to v is taken common. In the bracket you will have 10 upon 1000 plus 90 upon 1000. So 15 upon 1000 is equal to v. Denominators are same. So 90 plus 10 numerators we will add 100 upon 1000. Now keep v on the right hand side and here just bring it on the left hand side. This 1000 will go in the numerator and 100 will come in the denominator. 1000 will get cancelled off. So your common velocity is 15 divided by 100. So 0.15 meters per second. Very simple, as we have done in solved example number 2 today. Just writing the formula, copying the values properly, substitution and calculation. Let us move towards the last solved example, question number 7D. Same as question number 7A, only values are different. A person swims 100 meters in the first 40 seconds, 80 meters in the next 40 seconds and 45 meters in the last 20 seconds. What is its average speed? First, you have to calculate the total distance travelled. So the total distance travelled is 100 meters plus 80 meters plus 45 meters. That comes out to 225 meters. Now the timing, total timing is first 40 seconds. So 40 seconds plus 40 seconds plus last 20 seconds. So 40 plus 40, 80 plus 20 comes out to 100 seconds. Now very easy to calculate the average speed. Average speed is total distance travelled upon total time taken. Substitute the values. 225 divided by 100. You will get the answer as 2.25 meters per second. So the average speed of the person is 2.25 meters per second. With this, I announce that the first revision for your first online assessment exam, which is going to begin from the next week, Saturday, is over thoroughly. Each and every chapter we have revised in all the terms with respect to diagrams, numerical examples, everything. Once again, before the exam, we will have a short revision. Two chapters we will revise in one day. And now, without wasting time, we are going to start with a new chapter for our first terminal exam. Chapter number 8 from section B, Useful and Harmful Microbes. Look at the word microbes. Microbes or microorganisms means what? They are the minute organisms that are invisible to the naked eye and can be seen only under a microscope. So which are the different microorganisms or microbes which you find around you? They are bacteria, viruses, fungi, algae, protozoa, etc. Now out of these microbes, some of the microbes can be harmful to human beings. The name of the chapter is Useful and Harmful Microbes. All the microorganisms which you see around you in terms of bacteria, viruses, all may not be useful. Some of them are harmful. How harmful? They can cause several diseases not only to human beings but also to other living creatures like plants, animals, birds, etc. You have different examples of microbes, harmful microbes around you. Influenza virus, it causes flu in which you have fever, or a recent example, a good example which is going on in progress now is the SARS-CoV-2 virus. You know its full form? SARS stands for Severe Acute Respiratory Syndrome Coronavirus 2, which has created a great pandemic in the present situation. So really this virus is a very harmful virus. Then which are the different useful microbes and what do they do? So some microbes, they are used in the production of different antibiotics. Now harmful microbes, they cause the diseases, whereas useful microbes, they are used in the preparation of different antibiotics which are used to cure the diseases. They are used in the production of different vaccines, biogas, curds, etc. They are called as useful microbes. So our first topic today is about the useful microorganisms which you see around you. And under that you are going to study the first one, that is LACTOBACILLI, second one RHIZOBIUM, and the third one is yeast. So let us begin with the first useful microbe, LACTOBACILLI. Now LACTOBACILLI is a gram-positive bacteria. What do you mean by the term gram-positive? Two types of bacteria are there, gram-positive and gram-negative. Gram-positive means this bacteria, they have a thick peptidoglycan layer and no outer lipid membrane. Whereas gram-negative bacteria, they have a thin peptidoglycan layer and they have an outer lipid membrane. So this LACTOBACILLI is a gram-positive bacteria. They are minute in shape. So LACTOBACILLI means it is a bacteria, a microbacteria. It is rectangular in shape and minute in size. They are anaerobic bacteria. Anaerobic means they can produce the energy without the use of oxygen. In the absence of oxygen, they can be helpful in the production of energy. So anaerobic, so absence of oxygen. And this LACTOBACILLI, it is a type of bacteria which converts the lactose, which is the sugar in the milk, into lactic acid, and this process is called as fermentation. So a very useful microbe. Why? Because here what happens, when the lactose in the sugar in the milk, it is converted into lactic acid, the pH of the milk decreases, causing coagulation of milk proteins, and thus the milk proteins, they are separated from the other constituents of milk, and this is what happens when milk changes into yogurt. You have tasted yogurt. It has a specific sour taste due to the lactic acid. The low pH, it destroys the harmful microbes which are present in the milk. So a very useful microbe used in the production of different dairy products. Lactobacillus genus is one of the most important, and they are important where in the development of dairy starters, which play a crucial role in souring the raw milk and is one of the best sources of probiotics. So let us move towards the probiotic yogurt. You have heard about the probiotic yogurt. Now, this probiotic yogurt is one of the popular foodstuffs known to us nowadays. Useful microbes like lactobacilli are added to this eatables, and such eatables are healthy because they kill the harmful bacteria like Clostridium which are present in the alimentary canal and help to improve our immunity, our immune system. Now, where is this mostly used? This probiotic yogurt, it is most commonly used for, now this part you will not get in the textbook. This information I have obtained from the Google net. You should know the importance of this yogurt. Very less amount of information is given in the textbook. If you search for probiotic yogurt or for lactobacilli on the Google net, you will get ample of information, very informative and very interesting. So kindly go through the matter. They are most commonly used for diarrhea, including infectious diarrhea and diarrhea in people taking antibiotics. When people take antibiotics, then the heat level of the body increases, and to lower it and to improve the immune system, and you can say the abdominal discomfort, this probiotic yogurt is consumed. Useful in general digestion problems, irritable bowel syndrome IBS, and colic in infants. What do you mean by colic? Colic means a type of situation in small infants where they just go on crying for no reason. Means somewhere they are facing some abdominal discomfort which cannot be told by them, but they express in terms of constant crying, and then some companies, they have brought some probiotic, you can say like gripe water and all in the market, which is very useful in this case. So lactobacillus is thus a type of bacteria which is found in our intestine and very useful, you can say microbe. And let us move towards the general uses of lactobacilli. The first use is various milk products like yogurt, buttermilk, ghee, cheese, shrikhand, etc. can be obtained by fermentation of milk. Here, in the process of fermentation of milk, lactobacilli has to be added. Second, lactobacilli fermentation is useful for large-scale production of cider. What do you mean by cider? It is an alcoholic drink which is made from fermented apple juice, cocoa, and pickles of vegetables. You know, when you get a pickle in the market, a typical sour taste is experienced. That is due to the presence of lactobacilli. Lactobacilli and some other useful microbes taken together are used to treat abdominal discomfort. Just now I have told you, when there is some unnecessary stomach upset, then this lactobacilli with other useful microbes in the form of medicines or yogurts is consumed by the person. Leavened fodder offered to domestic cattle like cows and buffaloes is the fodder fermented with the help of lactobacilli. The lactobacilli fermentation process is used to make wine and some types of bread. So these are the general uses of lactobacilli. After the study of the useful microbe lactobacilli, let us move towards the next one, that is RHIZOBIUM, known as symbiotic bacteria, again falls under the category of useful microorganism. What is, you can say, RHIZOBIUM? RHIZOBIUM is a genus of gram-negative soil bacteria that fix nitrogen. Gram-negative. Just now in the beginning I have told you the difference between gram-positive and gram-negative bacteria. Now this RHIZOBIUM, it is a bacteria which is found in the soil that helps in fixing nitrogen in leguminous plants. They are rod-shaped. Why rod-shaped? Because they belong to the Bacillus group. So they are rod-shaped. You can see here the structure of RHIZOBIUM. Now, to study about this RHIZOBIUM, it is a bacterium which is found in the soil, helps in fixing nitrogen in the leguminous plants. Now, what is the role and importance of this RHIZOBIUM? In the previous chapter, in chapter number 7, when we had studied the nitrogen cycle, that time under the important processes of nitrogen cycle, the very first process, if you can just remember, is nitrogen fixation. There I had told you conversion of nitrogen into nitrates and nitrites. So the first importance of RHIZOBIUM is RHIZOBIUM, which is living in the root nodules. They supply nitrates, nitrites and amino acids to that plant, and in exchange get energy in the form of carbohydrates from it. Such mutually beneficial relationship is called symbiosis, and hence they are known as symbiotic bacteria. Now this rhizobia, they produce nitrogenous compounds. From where? From the atmospheric nitrogen. However, for this process of nitrogen fixation in the soil, they need leguminous plants, for example beans, sweet pea, soya bean, etc. as the host. They cannot do it directly in the absence of leguminous plants, and hence beans and pulses, they are the rich in proteins due to the nitrogenous compounds which are made available by this rhizobia. Now after you harvest a leguminous crop, the leftover roots and other plant parts are deliberately dumped in the farm soil to maintain its bacterial population. Here the use of rhizobium, it has really helped to reduce the use of chemical fertilizers, and hence the adverse effects which are caused by the use of chemical fertilizers is also lowered. It has also really helped the farmers to reduce the expenses on fertilizers, and thus really works as a benefit and advantage to the farmers who have their fields. Now the next small topic is about rhizobial inoculation. What do you mean by rhizobial inoculation? Nowadays, seeds which you get in the market, they are coated with rhizobial solution or powder before sowing. After sowing, the rhizobia enter the plantlets, and this is called as rhizobial inoculation. This experiment, it has really helped in the supply of nitrogen to cereal and other crops besides the leguminous crops, because this rhizobium, they live in the root nodules of leguminous plants. So after the application of this rhizobial solution or powder to other seeds, this has really helped in the supply of nitrogen to other cereals and crops also besides the leguminous crops. And in this way, rhizobium is really a very important, a very useful symbiotic bacteria. With this, we wind up with our today's session. The last useful microbe is yeast, which we are going to start in our next session. One small homework I would like, not a homework I would say, information which you have to obtain from the net. The next useful microbe which we are going to start is yeast, which is a very important, you can say, item or a supplement in the preparation of bread which you get in the market. So go through the Google net and see how this yeast is useful in the preparation of bread. how this yeast enables us to get soft and fluffy bread. So with this, we complete with our today's session. Before attending the next session, kindly go through the remaining chapter number 8. We are going to start with the next topic, that is antibiotics and the harmful microbes. So when you attend the next session, kindly go through the topics so you will be known to certain names and the session will be very interesting. Till then, stay at home, stay safe, keep your completion of books in progress and start your studies, because very early we are going to start with our first online assessment. Thank you, dear children.